Yep.
So we have like input, which is like 29264, and then you can only do one operation, right? Like one swap to which is like to find uh the largest one, right? Like the largest value, right?
Yep. You can do it at most once. So that means you can either do it one time or zero time. Up to you.
Nice. I see input. And then you need to output like the largest value
Yes.
at most one operation. Gotcha. Uh, I want to ask like, is this like just like the integer number, right? Is this not like real number or anything, right? Or is it
Uh,
like a string or is it an integer?
Good questions. First question, yeah, it could be just integer. And second question, this integer can be very big. It can have like, let's say, 1 million digits. So, so
Like
yeah,
1 million, right? Sorry.
yeah, 1 million digits. So the input type for your, I guess, your function or your application could be a string.
Oops. All right, I see. So 6 million digits. Okay. And then, so for the case, it is like, so it's just like, so for the case, it has one digit. So it's gonna be like, you just swap it 0 times. So you don't have like, so it's gonna be the largest number, right?
Pardon?
Like for if you have like just one digit,
Mm-hmm.
so it's just you just need to swap one time. Like you don't need to swap it. It's still like you're gonna return to the max, right?
Correct, correct. If it is
Oh,
just a one-digit number, then you can just return it as it is.
digit. So it's just like, and then how about like is that like a negative case as well? I wonder like how we're gonna manage it.
Well, let's say we already have positive numbers, so no minus, etc.
Uh, so no minus, right? So we just focus
Yes.
on, I see. And then if no negative, okay. So so there's like one, so I can't just like come up with one solution that I think about for now, which is, so for example, like if you have like those digit, you can convert it to single digit. Like for example, you have like 9264.
Mm-hmm.
So I want to convert it to maybe like 9264. I want it to be like maybe I'm gonna split it to 9, uh, and then 2, and then 64. And then so from here, uh, I feel like I will traverse
Mm-hmm.
backward, like from the right to left. And then I will like find the digit. I will try to find the digit. I'm gonna have like two pointer, like from left and then from the right side, to manage like which one I can't really swap because um or think about like we might be like find like the rightmost max from that because so 29264 and then you can do one swap. So we want to have like 9624, which is like the largest value.
Mm-hmm.
9264. Okay. So I see. Okay. So and then so when we go backward, we're gonna try to see like if the current digit is it like less than the digit that we like the max digit that we have found. So if we find if we were able to find the max digit, we can just for the left and right, we can just mark it as a max position because we want to swap it. to the max, right? And then you want to swap like, you know, the larger one. So you want to find out like the least one from the left, and then you swap it with the max from the right, right? So if, you know, like the current one is less than the maximum digit found to the right, to the right of that, you need to mark like, you need to mark like left is the current one, and then you mark the right is the max one. So, and then if the current one is larger than the max one, you need you know like the current one is the max values right now, right? So if we find like, you know, we have the pair, which just means like we have the left and the right, and then we have a pairs of that to swap, we can swap like, so I'm
Can you walk
thinking
me
about
through
like,
one example?
sure. I can find out like, so I think about like, we're gonna do like the left and right pointer. We saw like, you know, maybe like for zero, like, no, not zero, -1, because like we don't want to point it to the beginning of that. And then, so we're gonna loop backward. Uh, so we can do like, we loop from the right to left. So we will loop from the right to the left. And then we say it's like, if this digit, and then if this digit, and then we have like, we need to find the max digit as well, right? So maybe like I'm gonna have the max digit as well. For this one, gonna be maybe like, it's pointing to 4 right here, which is like the length of that, the length of the digit. Which is like, it's point to the last one. So here I will say it's like, if I'm gonna start from here, I compare it to the max digit. If it is, if the current one less than the max digit, um, we will match like, you know, left. If it's like
Less than 3, do you mean? In this case?
like 4 less than,
Because
yeah,
max digit here could be to 3, right?
yeah. Uh, like no, like the digit, is I less than the digits at max digit.
Okay.
Yeah, and then you find out like left right now, the left pointer, it will point to the current, which is I, and then the max digit gonna be the right. So I want to hold the window like that, and then if the digit at I larger than the digit at max digit, so you're gonna say it's like max digit right now is the current one. So for example, like, so when you go in here and you say it's like the max digit is here, so you find out like, hey, 6 is like larger than 4, and then you will mark like that's the max digit. Max digit will be there, which is like you find out. So you keep looping to the left, and then you will find like, you know, uh you will find out like, max digit will be 9 in this case. I uh right, like 62964. Max digit, loop from the right and the left, and then if you keep looping, you will store the max digit based on the I, and then if we found it, so you keep left is like the largest one, and then left is the current one, and then we'll find out like and then you're gonna do swap. So left. Like this, like that. I think there's a problem with the logic with the max digit that I'm thinking it. Let me think of it. Because I'm trying to find like the rightmost maximum digit. So we would say it's like maybe we just find like we can start. So yeah, so if we find that, I think the max will point to the 9. The max will point to the 9, and then because left and the right is based on, because like when we are at digit 2, which is like I equal 1 right here, we have, so I want to say it's like, because like first it says like max is from here and it's go here, so max is 6. So we find, so we have digit 2, we digit at I, which is like 2, and then digits as max digit is 6 right here. So we're gonna have like, we have at that left is like left is like 2, and then right gonna be 6 at that time. And then set, so we need to, so we have like, so we're gonna do like left is 1, and then right is 2 at that operation. So so we need to mark like like, so when we have that, it means like, hey, we find out like there is the possibility that when we swap it, the number is getting bigger. It's like, we say it's like digit at I, right? And then we say like digit at I is less than digit at max, right? It's my index, right? So if that case happen, there's like the case that we can swap. And then when we go next to this one, we will find out like, hey, the max digit is right now is gonna be 0.29. So we update that. We have like digit 9, and then the digit max at that time is 6. And then so digit I, so for the next iteration, digit I gonna be 9, right? And then the max is still 6, right? So 9 is greater than 6. So right here, we just need to update the max digit again. But like we don't really do anything with that. So at that point, we just update the max digit, and then we still hold this value, right? So at the end, we say it's like, hey, left is not -1 anymore. It means like we find out some pairs that we can swap, right? And then we just need to swap the left and the right based on that digits array. So do you understand? Are you clear with what I'm coming from?
I'm not sure if I fully understand your intention. May you have may you give me like a pseudocode, or if you use Python, then you can write out the code for the
Sure.
for the main part of the function as well.
So for example, like right here, so I think let me just like, so for example, right here, I think I can just like go through this one a bit.
Okay.
So I'm gonna start like so I'm gonna start from this, and then the max, for example, like the max at the time is 4. It's gonna be 4, the max index.
Mm-hmm.
And then right now, left and right is like, left is like -1, and then right is -1, right? So you go backward.
So you have like 3 pointers, right? Max index.
Yeah, three
start
pointers.
from the right. Okay.
Yeah,
And
yeah. Because like
is...
I wanna so the max, I wanna find like the largest one to the right, because like you need to find the largest one, right?
Mm-hmm.
And then to the right to swap it. And then 2 pointer left or right is like the 2 pointer that I know, like which pair that can make it to that I can swap. So I keep going here, and then I say it's like here I miss 6, and then 6 is so digit I right now. I here is a 6, so it's gonna be 2. So I digit at 2 is like 6, and then the digit at I right now, it is larger than this one, right? Which is 4. So it's gonna be the max digit. Max index is gonna be, it's not 3, and then it's gonna be 2, which is like 6 in the value.
Hold on. Why are you jumping to 60 directly? Because both the left pointer and the right pointer at the beginning is at -1, right? Why can like jump into that position?
Yeah, but like digit at I is like larger than digit.
What is I again?
I is like you go backward, right? It's a pointer that you go backward.
So is it like another pointer beside L, R, and max index?
Yeah, I is like you loop from the left, like the right to the left.
Okay.
You loop. So I is like the index that you go from the right to the left, and that's it. And then left and right is just like 2 pointer that you want to swap, like the
okay.
mark point.
Okay.
Right?
Okay.
So you say it's like here the digit is larger than the max, so that's why like you update the max, which is like the index is 2, which means 6, and then left and right is still like -1, right? And right is -1, right? And then you keep going. So now you jump to 2, right? You jump to 2. Like I is like 1, which is like 2. So you will compare it to the max index again. And now you say it's like the digit right now at I is less than. It means like, hey, there's a possible way, because like if you swap from the right to the left, it needs to bigger than, right? So there's a possible way that you can swap to have the bigger values, right? So I think now the max is still the max index is still 2. And then now left is gonna be 1. And then right is gonna be 2. Because you will say it's like right is gonna be the max index, and then the left gonna point it to the current position, right? So and then you keep looping. So now is I gonna point to 9, and then you say it's like 9, and then the max index is still point to 2, so 9 is still greater than 6. 9 is greater than 6 right now. So you just need to update the max index in here. And then you say it's like it's going to be 0. And then you don't have any values to traverse. So you're going to have left and right here. And then you can just do one swap, and then you can find the one. So that's it. So, yep. So are you pretty...
Yeah, could you write out the code for it very quickly?
Oh, yeah. And then for the time complexity, I'm going to have like O of n right here. And I'm going to have like O of n as well for this array. Because I split the number to an array, right? So it's going to be the number of how many digits it is. So the worst case is going to be like 10, like 1 million of that. So that's still fine, right?
Yeah, I'm not so convinced that this solution will work yet, but I guess we need to like code it out and look at the code. Yeah.
Oh, okay.
So if you can do it quickly, then that'd be great.
Oh yeah, sure. So I'm gonna have like, whatever it is, like the max digit, the max number as well. And then I just put like 1 digit in, right? And then, so I'm gonna try to split it in the list. And then I'm gonna try to make it to string. So for now, I'm gonna have like the max index, and we have like left and right as well. So the max is pointing to the last position of the digit, like the last one of the digit, so which is like the length of the digit. Subtract by 1, and then you're gonna start with 1, negative 1. So so if you loop range of maybe like I have like you're gonna say length of digits. So you go backward, and then you will say it's like if the digit at I less than the digit at the max index. Oh, so you will say like left and right gonna be you will update max and right, and then elif the digit at like that current one, which is like greater than the digit max one. You will update the max index, going to be I. So right now, if you can surpass it, you will have like, if there's a pair, it means like if the left is not, negative 1 anymore. So it means like you have a pair to swap. You say it's like digit at the left. Oops. I'm gonna and then you swap the digit and the right. And then at the end, you just need to return to like the whole number, which is like, like you can do like in there, and then you join it together. You join the whole digit together. So that's what I'm pretty much think about.
Okay, could you run it with the above example?
Sure. I think let's do. Let me find out like print maximum swap with 9264.
Okay, let's try with another example. Let's see. How about this one? For 2, 7, 9, 8, something like that.
Or 2798. Or 2798. So
Okay. How about this one?
Oh, like all of those cases?
Yeah. Each number is
Okay.
one test case.
Okay. Let me try this one. So it's supposed to be
Okay, that one is good.
and then let me this one.
Okay.
6, 5. And then this one is like
Um,
5. It's swap 9 and 5.
Okay. Yeah, I think this one is good. Hold on. Just give me one minute.
Yep.
Okay, so you swap. I mean, you change the pair if digits I is less than digits max index. Okay,
Yep.
max index is
Because
yeah.
here
I see.
because the max is like you try to find like the max on to the right side, right?
Yeah, on the right of
So
I see.
yeah, and then if you find something like because you can just do one operation, right? So you find something on the left, which is like less than on the right, so you just mark there, and then you're gonna swap it later on, right? So yep.
So basically, you try to make a swap between I and the maximum of all the digits on the right side of I,
Yes, that's correct.
and you try to do do the swap as far on the left as possible. I see.
Yep.
Okay, I think this one is good.
Yep.
Good
And
job.
then
Yeah.
yeah, and then like it's big O of n for the time, and then big O of n because like it depends on the number of digit for the worst case scenario. So the space as well. Yep.
Okay, okay. Yeah, time complexity of this one is O n. Space is yeah, space is also O of n. Yep, that's good. Yep.
And then yeah, and then I don't need to do the right run for you, right? Because I think I did it on the example as well. So if you want me to do the right run, I can do it again as well. So
Sorry, to do what?
like the right run of the program, stuff like that.
Sorry, the
Like
right
right
one
run.
was
Like
right
right
one. Yes,
run.
yes, yes, yes. Yeah, yeah,
Yeah.
yeah. You don't need to. Okay. Yeah, I think this is good. We still have time, so let's move on to another problem.
Yep.
Okay. Give me 1 minute.
Yep. Sure.
Okay, so for the next problem, let's say you're managing a social network like Facebook or Twitter or something like that, and on your social network, there's a friend relationship, which means a person can become friend with another. So let's say other side there are n people. You still hear me, right?
Yep.
Okay.
I'm concentrating. So
Okay. Okay. Yeah.
yeah,
Yeah.
yeah, yeah.
All right. So let's say there are n people, and we can number them from 0 to n minus 1 as usual. And you also have the logs of all the activities of making friends. So let's say they'll have n m log entry, and each record of the log will include 3 numbers, t, x, y, where t is a timestamp, x is the x and y are the index of some people, of some users on the social network. So for example, if we have t, x, y equal to 3, 0, 2, it means that at t equal to 3, then user 0 become friends with user 2, something like that. And you have m of these log entries. And also, based on this friend relationship, we can define another type of relationship called acquaintance. So we can say A is an acquaintance of B if there are some chain from, let's say, for example, A to C, C to D, D to E, and goes all the way, somehow connected to B. So let's say if A is a friend of a person, that person is a friend of another person, and it goes all the way to B, then we can say that A is an acquaintance of B. Okay, and given all of these, we need to find out the earliest time that all the people, all users on the platform become acquaintance of each other. So let's say we have the following logs. Okay, let's say we have six people, and we have m equal to 8 log entries of users making friends with each other. So at t equal to January 1st of 2019, user 0 and user 1 become friends. And at 2019, January 4th, user 3 and user 4 become friends. And yeah, it goes on like that. Then the output could be 2019, March 1. The reason is because so on January 1st of 2019, 0 and 1 become friends. And then after that, 3 and 4 become friends. And then 2 and 3 become friends. Then after that, 1 and 5 become friends. Then 2 and 4 become friends. So, okay, let's say at this moment, only 1 and 0 connect to each other. And at this, and for the next record, we have 0 and 1 connected to each other, and 3 and 4 connected to each other. And next one, we have 0 and 1 with each other, 2, 3, and 4 connected with each other. And then when 1 becomes friend with 5, then we have 0, 1, 5, and 2, 3, 4. And after that, 2 and 4 become friends, but they are already acquaintance. So we have these two groups. And only when 0 and 3 become friends with each other, it is the first time that all 6 people, all 6 users, become acquaintance of each other. So we have all the users connected to each other here. Okay, so that's why we need to return the timestamp of this event here, which is 2019 March 1st.
Let's see. Wow, it's a big problem. Yep. So let me just verify from my understanding. So the input right now is like you have a list of logs right now with the timestamp and then the index of like some users on the social network. So for example, right here you have like Jan 1st of 2019, user number 0 gonna be the friend with number 1, right? So it means like based on that one, it's gonna based on like, if like they are friend and then so 0 and 1 are friends, and then later on 1 is the friend of 5 on February, right? Like February 2019. So it means like 0 gonna be acquainted like with 5 as well, right?
Pardon?
Like so you have like 0 and then 1 know each other from like Jan 2019, but like later on you have on February like 2019 you have 1 and 5 know each other, right?
Yep.
So it means like now 0 and 5 are acquaintances as well, right?
That's correct.
I see. I see. Okay. And then it's really based on the chronological, right? And then
Yep.
so and then the return value is gonna be the earliest time that all users become acquaintance. So it means like you need to find the time that all users need to become of the like the corrected graph, right? Like for like it's gonna return the timestamp, right? That everyone know each other. Okay, I gotcha. And okay, and then so I see. So I see. So it's really reminding me about like the graph problem in this case. When you try to build like connected graph, that we would try to have but I'm thinking as well. So there's just one, right? There's just one relationship in the same timestamp, right? So within the one timestamp, there's just one zero and one, right? Or there are like multiple friendship blocks at the same time.
Sorry, could you say that again?
So with one timestamp, is that like just one friendship, or there are like multiple friendships
Oh,
created? And
let's say that all the events are different times.
okay, so it means like one timestamp is gonna be one friendship, right?
Yes, at most
I
one.
see. Almost one. Okay. Uh, and then so what happened like if the friendship block already like connects everyone as acquaintances at the beginning, like
Pardon? Is that a
at
question?
the
Yeah.
like at the earliest timestamp. Oh, because one timestamp is just like okay. Oh yeah. I'm just misunderstand because like I
Okay.
thought like the I'm thinking about like if the earliest timestamp is like it has like the all relationship like they are acquaintances at the earliest one like right at the beginning, so we don't really need to find out. But yep. Okay. So for this problem, like I'm thinking about a graph problem that we try to connect people. So think about like this is like one vertices and then it connect to the next one, like the next node. So node zero connect to node one at this kind of timestamp, and then we have like this node zero one and then connect to this node. So I think like to find out like if those are acquaintances, I just need to find out like is there like I've tried to build graph and then maybe like think about is there a way to go from this node to this node? So for example, like I try to find out like all possible acquaintances of node zero. So I try to really see it. I try to really see it like, from zero, what are possible ways, what are possible paths that we can explore. And then if from zero we can go to five, it means like all of that path, like people on that path, they are acquaintances, right?
Mm-hmm.
Uh, so, and then, so before that as well, I think I need to, this one, so the input is in chronological order, right? I don't need to sort it, right?
Um, let's say that originally they're not sorted.
Oh, they are not sorted.
Yeah.
So, uh, so I see.
We are,
So,
we are running out of time, so you can just give me the idea of it, of
okay.
the solution that you have. We don't need to
Yeah,
like
so I'm
implement
thinking
it.
about like something about like union find.
Mm-hmm.
Just like because like here I want to find like I'm gonna do like two operations. Like we need to find it. Like we need to find out the root, which is like the people that we know, right? And then you can see like who acquaintances from that people, which is like the root. And then after like you connect them, you're gonna merge two components if two users form a friendship,
Mm-hmm.
and then you will find it you based on like and then you're gonna try to find it based on um the size, the size of that. Like there's a possible path to go, and then you sort the timestamp to that process the friendship in chronological order. And then for each friendship, you have like TXI to be, and then you're gonna look at like X and Y. So if they are already the same component, you just need to skip the lock. If they are not in the same component, so you try to unite them, and then you reduce the count of the components by 1.
Right.
And then after like, after like you're gonna you're gonna unite each component, right? So if you successfully unite them, you check like if all users are now in the same component or not. So because like in the union one, we just want to find like there's one union, right? And then the first timestamp at which all users are connected gonna be the earliest one, because like we sorted, right? So gonna be the earliest one that all users become acquaintance of each other. Yep, that's the main idea that they think. And then this one is gonna be like it's based on like it's gonna be M lock M. M is like the lock entries of that union find.
Okay. Yeah.
Yep.
Yeah. I think that's a good solution. Actually, I think that is a optimal one for this problem.
Yeah, but
So
like
good
that's
job.
I didn't really cook that out, but like yeah, that's yep. So that's the ones I'm thinking about.
Yeah. Okay. I think we can conclude here. Before concluding, this is a follow-up question for this problem. You can think about that if you have some time.
Yep.
So follow-up could be, what if two users can unfriend each other?
Oh, yeah, I see.
Yeah, but not for now. Yeah, if you have some time, you can think about that. But I think this is good. Yeah,
I
okay.
see.
Thì anh nghĩ là em làm khá tốt với cả cái bài phỏng vấn này. Yeah.
Yeah.
Tất nhiên là anh nghĩ là anh cũng hơi hối hận tại vì cho em hai cái bài nó không nó vẫn còn hơi dễ so với trình độ của em. Hai bài này thì đều có mức
Ồ,
medium
dễ
thôi.
à?
Yeah.
Dạ, em
Không
thấy
thì
cũng khó.
ban đầu thì anh nghĩ là anh hơi băn khoăn việc là cho một bài medium hay bài hard, nhưng mà thường thì theo kinh nghiệm anh phỏng vấn Google hay là những công ty Phan hồi trước thì dù là Phan nhưng mà phần lớn câu hỏi của họ cũng đều ở mức medium thôi. Ngày trước anh phỏng vấn Google thì anh nhớ là đấy cũng 3-4 interview gì đấy thì cũng phần lớn là medium thôi, chỉ có một hai bài là hard đấy. Thì anh nghĩ là em cũng chỉ cần làm tốt ở mức medium là khả năng có offer rồi. Đấy thì note ở đây thì đầu tiên là lúc mà vào thì em có clarify được những cái câu rất là quan trọng, đúng không? Thứ nhất là đầu tiên nó là integers hay là có thể là decimal, thì đấy thì đây là một cái câu hỏi hay. Ok. Tiếp theo là em cũng có clarify được là đây là string hay number, nhưng mà có một cái điểm em miss mất là mặc dù là anh đã confirm lại với em thì đây là string, nhưng mà sau đấy thì em vẫn treat cái số này dưới dạng number. Đấy.
Ồ, em quên mất.
Cái này thì em miss mất đấy. Nên kinh nghiệm ở đây thì tức là em vừa hỏi xong người ta trả lời thì em nốt ngay vào trong cái Google Doc hay là trong cái code path của em ấy, thì sau này mình sẽ không miss. Đấy, và tất cả những cái như thế thì nó còn giúp em được một cái rất là hay sau này, tức là ví dụ ngay bản thân thằng interviewer nó trả lời xong câu hỏi của em cũng có thể nó quên hay là gì đấy. Sau này thì nếu mà em nốt vào đấy thì sau này nếu mà thằng interviewer nó có gọi là quên hay là tự dưng nó bảo là ô đâu tao có đâu yêu cầu mày làm này, thì em có một cái gọi là gọi là paper trail để đấy, đấy đầu tiên là chúng ta đã đồng ý làm này rồi, đây mày quên thôi là gì thôi đấy. Thì communication đấy nghĩ là em làm rất là tốt đấy, cũng ít có điểm gì để chê cả, chỉ có điều là đoạn có một cái rất là nhỏ như này đó, tức là đoạn đầu thì anh thấy em giải thích hơi lâu nhưng mà không có example đấy. Giải thích thì kinh nghiệm của anh là nếu mà không có example thì thường lại interviewer họ sẽ có khả năng là họ sẽ chưa hiểu là mình định làm gì, nên là thường là mình vừa giải thích mình vừa come up với một cái example để mình gọi là walk họ through cái example đấy thì thường là nó sẽ nhanh hơn. Với cả một cái nữa là đây là kinh nghiệm của anh thôi, tức là thông thường thì những cái bài này em nên đưa một cái solution brute force trước. Đấy. Tại sao lại đưa một cái solution brute force trước? Tại vì thường thì em làm thì tức là mọi người nghe bài toán thì mọi người thì anh hiểu là ai cũng muốn là đưa một cái solution tối ưu ngay, đúng không? Mà nhiều khi là mình sau đấy mình bị struggle hay bị gì đấy, hay mình gì đấy mà mình không làm được thì ít nhất là mình nên có một cái brute force solution trước, để sau này nếu mà mình không come up được với optimal solution, hoặc là sau này mình come up được rồi nhưng mà lúc implement mình bị thiếu thời gian, mình không thể hoàn thành được, thì ít ra là mình còn có một cái brute force solution để người ta tích vào trong cái nốt của người ta, là đây ít nhất thì bạn này cũng có code được và code đúng cái đã. Đấy. Bao giờ thì thang điểm của người ta bao giờ cũng là các cái level đầu tiên là phải code được đã. Nếu mà không code được cái gì, không code được một cái solution đúng thì nó sẽ bị trừ điểm nặng hơn là không code được optimal rất là nhiều. Đấy. Thì đấy là một cái kinh nghiệm thôi. Ok.
Tại vì nãy em quên nghĩ tới cái brute force đầu tiên luôn á chứ. Mới vào cái nghĩ
Cái đấy. Thông thường thì em chỉ cần nói ý tưởng brute force và gọi là confirm với cả interviewer là, và một khi thằng interviewer nó bảo nó confirm lại với em là tao nghĩ là brute force này đúng đấy, thì là được rồi, chứ thực ra em cũng không cần phải implement lại cái đấy đâu. Lại gọi là một cái bài exam mà có 10 điểm thì bây giờ mình cứ phải gọi là lấy chắc được 5 điểm cái đã, kiểu như vậy. Đấy. Thì ok, anh nghĩ rất là good. Anh nghĩ là nếu mà gọi là thang 4/4 của Google thì anh nghĩ là bài này hoàn toàn anh có thể cho em 4 cho cái interview được. Đấy. Đấy. Ok. Bao giờ anh dùng này?
với gọi là gọi là giải được đúng không anh, còn ra bài nào mà không biết giải cái là toi luôn.
Ờ.
Nếu mà trong trường hợp mà nó gặp cái câu mà mình không biết giải thì mình nên làm gì ạ?
Không biết giải thì đầu tiên là em cứ gọi là nghĩ được solution brute force thì em cứ gọi là cứ nói ý tưởng brute force cho người ta đã. Đấy. Còn tất nhiên là sau này nếu mà gặp một cái bài nào khó quá mà mình không nghĩ được tối ưu thì thằng interviewer nó cũng không có để mình cứ ngồi nghĩ mãi đây đâu. Đến một lúc nào đó thì nó sẽ phải đưa hint cho mình. Đấy, thông thường như thế. Còn gặp thằng nào mà nó gọi là nó củ chuối quá mãi không chịu đưa hint thì gọi là em canh thời gian đấy. Thì thường những cái bài coding interview này, nếu mà em dùng Python ấy, thì theo kinh nghiệm của anh là không có bài nào mà em không thể implement được trong từ 10 phút trở xuống cả. Đấy, nên em cứ canh, ví dụ từ giờ đến lúc hết interview mà còn 15 phút mà em chưa nghĩ ra được solution optimal thì lúc đấy em cứ, nếu mà lúc nó chưa đưa cho mình hint thì em cứ chủ động hỏi hint từ đó. Đấy, kinh nghiệm anh như thế. Thì thường là 10 phút là sẽ đủ để mình implement, và 5 phút cuối cùng là để walk through rồi follow up các thứ. Đấy, để có thể conclude được cái interview đấy.
Nhưng mà ok, tại thứ năm này em cũng phỏng vấn này, thứ năm này là super day luôn, nó hỏi một lần bốn round luôn. Không biết tại sao là năm nay nó chơi một lần 4 round một ngày luôn á.
Bây giờ vẫn là phỏng vấn theo kiểu là virtual đúng không?
Virtual anh.
Ok.
Nên là cũng hên xui lắm anh, mấy cái này cũng hên xui.
Ok, không sao, anh thấy em chuẩn bị cũng tương là tốt rồi đấy, mọi thứ đều
Đâu em
ok.
chưa giải nhiều đâu. Đợt
Nhưng
này
mà
em có...
anh thấy mọi thứ đều ok, tức là em giải được bài mà communication cũng tốt, mà gọi là cấu trúc của một cái phần interview thì em cũng nắm tương rõ, chỉ có một số điểm tương nhỏ đây để anh có thể có ví giúp em thôi. Đấy thì anh nhận được ra lúc nãy rồi. Thứ năm phỏng vấn đúng không? Ok.
Thứ năm này phỏng vấn nên giờ vẫn đang ngồi cày bài chứ, tại vì em mới luyện tầm tới hơn 3 tuần nay à.
Ok.
Còn trước đây em bỏ cả năm trời rồi, cái xong quay lại mình không hiểu gì hết.
Cả năm rồi à?
Cả năm rồi, lâu
Ok.
quá.
Không
Tại
sao.
tại có job sớm quá, cái xong chủ quan lại đi làm mấy cái dự án khác á, không ngồi ôn phỏng vấn.
Ok. Cũng không sao cả, nói chung là được thì
Nhưng
tốt thôi,
mà
còn không được thì cũng không sao cả, đúng không? Mình trong trạng
có
thái như
tật
thế.
thì còn gặp anh dài dài. Cứ đi
Ok.
mock interview suốt.
Ok.
Dạ.
Ok, vậy thì hôm nay mình kết thúc ở đây nhá. Sau
Dạ
khi
em
phỏng
cảm
vấn
ơn.
thì có gì thì em gọi là báo lại thông tin rồi feedback lại cho bọn anh nhá.
Dạ ok anh, trời em theo FSI nhiều mà em còn, tại vì đợt trước em chưa có mock interview cuối khóa tại em bận. Cái xong em học 2 khóa System Design đầu tiên, mấy khóa này đều chưa móc luôn.
À, ok, ok,
Dạ. Nên là đợt này em mới xin anh Nguyên cho đi móc thử để phỏng vấn.
ok.
Dạ.
Yeah.
Dạ.
Thông qua hai bài thì anh thấy là trình độ em cũng cũng ở mức rất là tốt đấy, nên đừng có tự ti quá. Anh nghĩ là khả năng của em là cũng 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 cao đấy.
Em giải lý code đều lắm anh.
Ok, vậy thì
Dạ. Ok.
ok bye em nhé.
Dạ.
Chúc
Em
em
cảm
may
ơn
mắn.
anh nhiều.
Yeah.
Dạ.
Ok,
Em cảm
bye
ơn
em.
anh nhiều ạ. Dạ.